We're going to go ahead and start target 2B. Today we are looking at the graph of tangent functions. So we're going to go ahead and explore our tangent function with some given angles here. I'm going to go ahead and label those my unit circle. Pi over 2, negative pi over 2, pi over 4, negative pi over 4, and 0. If I go ahead and label the ordered pairs at each of those points, I know this is 0, 1. This is 1, 0. 0, negative 1. And then I know for my pi over 4, I can create two 45, 45, 90 reference triangles. So I can go ahead and just use my side lengths like I did before when finding the the tangent values for these angles. So let's go ahead and explore our chart. We have the tangent of some given angles, and we want to find what that equals. And if we remember back to our work with the unit circle, we know that tangent is opposite over adjacent, which remember this is going to be our y coordinate over our x coordinate. So tangent of our angle is y over x. So we can go ahead and use that idea from our coordinates to evaluate our tangent values for each angle. So let's go ahead and start with our first one up here. Negative pi half. So down here we have x and y. Y is negative 1 over x, which is 0, and that will give us an undefined value. Let's look at that. We'll look at what that will look like on our graph in a few moments. And then if we go to the next angle, negative pi over 4, we have opposite over adjacent is negative 1 over 1, which will give us negative 1. For our next angle, angle 0, 0 degrees or 0 radians, we have y over x, so 0 over 1 will give us a 0. Up to pi over 4, opposite over adjacent, or y over x, we'll have 1 over 1, which equals positive 1. And then pi halves x, y, 0, 1, so we take y, which is 1, divided by 0, and again, that will give us an undefined value. So we have our table of 5 key points, although 2 of those points are not going to be points. They're going to be an asymptote, remember from algebra 2. Now if we go ahead and graph our tangent function, we will start with our asymptotes. So we know it's going to have 1 at pi halves, negative pi halves, and 1 at positive pi halves, because those values are undefined, which means our function, our tangent function, is never going to ever reach that value, because as we saw in our table, we can't divide by 0. So it is undefined at that point. Now we can go ahead and graph our other coordinates. We have negative pi over 4, comma, negative 1, 0, 0, positive pi over 4, comma, positive 1, and our function will increase from left to right. So it has kind of the shape of a cubic function in a way, and it will approach our asymptotes, but it will never reach those in either direction. So you'll notice that the period is between negative pi halves and positive pi halves. So if we find the actual distance it takes to complete one cycle, it's going to be pi. We can see our domain. If we graph, before we do our domain and range, let's go ahead and graph another period, and I'm going to include one on either side. So my asymptotes are going to occur at another pi units away, because remember it takes pi to complete one full cycle. I'm going to go pi units in this direction as well. And we're going to go ahead and just kind of like we did before, sine and cosine, copy and paste. So we have our midpoint here, that center. We go up 1, get down negative 1. And we'll do the same thing over here. Have that midpoint, up 1, negative 1. Okay, and that's what our tangent function looks like. So if we look at our domain, we know our domain is defined anywhere between these asymptotes. So it includes all values except for where these asymptotes are. And you'll notice that these asymptotes for our parent function occur at every pi units away, and they start at pi halves. So how we can write that is that it's all x values, but they do not equal. So all x's that don't equal pi over 2 plus any number of periods we add to that times pi. So the n is kind of like our number of periods that we're on in either direction, and pi is the lengthening period. So we include all values except for all of these asymptotes, which is what this is saying here. Our range, our y values, you'll notice that those are all real numbers. So all real numbers, or we would write that from negative infinity to positive infinity, interval notation. And then we have our vertical asymptotes given here at pi halves plus n pi. So we can see that our domain is just where all the x values that do not equal our vertical asymptotes. So we can go ahead and transform our tangent functions just like we did with sine and cosine. So go ahead and look at an example. We have our vertical scaling, which is a vertical, A performs a vertical stretch or compression. So it treats this, it's the same thing that it would do to sine and cosine. A causes a reflection across the x-axis, just like before. And instead of calling A like our amplitude now, right, we would get that from for our sine and cosine. This kind of controls that point that we are using it. The A is going to change the height of this point given here. So if A is greater than 1, we know it's going to be a vertical stretch. And if A is less than 1, it's going to be a vertical compression. Okay, we're going to go ahead and graph using our 5 key points, and we're going to include 2 periods. So right here, we just see we have an A value, and we're going to go ahead and see what that looks like. So there's no horizontal movement happening to our X. And we know that our, the period for pi, is pi. And that's going to make our interval, just like we did before finding those 5 key points, we're just going to divide that by 4. So the process is the same. We're kind of using that same idea. And once we look at our horizontal, we'll talk about that starting and ending point. We don't need that again for right now. We have just the regular pi. So if we go ahead and look at our table of 5 key points, just like we did before, we use our starting points. We're adding pi over 4 every time. And we're going to use our parent function for our y values. So this is undefined. And then remember, it goes from negative to positive. And it's also undefined. I like to include my asymptotes in the table because again, those are, even though they're not a point, they're still a key feature of the graph that we use to graph our function. So now what we'll do is we're going to go ahead and multiply by 3 because we can see our A value is 3. And so just like before, we're going to multiply our output values. So this will still be undefined, -3, 0, +3, and undefined. And we can go ahead and graph our tangent function. So I like to start with my asymptotes again. So asymptotes are at negative pi halves and positive pi halves. And if I'm including 2 periods, I'm gonna go ahead and just go in the positive direction. So I went another distance of pi. So again, I can see that this period is pi. This is 1 period. So my next asymptote is also pi units away. Now, if I go ahead and graph, I know that negative pi over 4 is halfway between 0 and a half, right? And we're going down to -3 this time, 0 and +3. So we use the same values again to graph the second period. And that will be 2 periods of our given tangent function. Let's go ahead and look at our last example, our horizontal scaling and translation. So just like before, the independent variable, our x, causes our horizontal scaling and translation. So we can use the starting and ending point from the parent function to perform our horizontal scaling and translation. So our parent function starts and ends at negative pi halves and pi halves, because again, we think about those asymptotes as being our starting and ending point. Even though they're not actually a point on the graph, it's a key feature that we use to navigate and find the period. So we're going to use the same process we did before for sine and cosine. So everything is pretty much the same except for the starting and ending point and then our y values. So those are the only things we have to change in our strategy. So now what we're going to do to graph our tangent function, we take whatever is inside of our tangent function and we're going to set it equal to our parent function starting point. And then we're also going to set it equal to our parent function ending point. So the process is still the same that we would use for sine and cosine. Now, the only thing that's different is our starting and ending point and also our y values. So we'll go ahead and just solve. So we'll add pi over 2 to both sides. So this means our asymptotes, or the starting point for this tangent function, is going to be 0. And the ending point for this tangent function is going to be pi. So I can find a period just like I did before, take my ending point and subtract it with my starting point. So that will get me pi minus 0, which is pi. So the period is pi, and the interval is period divided by 4. So same kind of thing. All right, so now all we have to do is just find our output values. So we start at 0, and we're going to add pi over 4 every time. So pi over 4, and then we could have 2 pi over 4 or 1/2, 3 pi over 4, and then we end at our ending point. So just like before, we start with our starting point, we end with our ending point, and we are adding that interval every time. So it's really just like what we did with sine and cosine. It's just we're starting, we have these different parent function values. The process is still the same. Now, if you remember from our first example, we know that the parent function is undefined, -1, 0, +1, undefined. So we start with those parent function values. And then we're going to multiply that by our a value. So we can see that a equals -2. So we're going to multiply everything by -2 before we graph. This will still be undefined. This is now +2, 0, -2, undefined. I'm going to go ahead and include my asymptotes. I like to highlight those in yellow. So they are every pi units away. So I'm just graphing 2 periods. I could keep going. And now I just go ahead and graph my values. So I start at my first point, pi over 4, and it's positive now. So now my function is decreasing because we have that negative. I go down to 0 and then down to -2. So now we are decreasing tangent function. And then I just use the same values again and sketch the next period.